In this video, we are going to look at network setup and configurations. We have a scenario, an office, and we want to ensure that there is redundancies. That means we have two routers, R1 and R2, connecting to the internet through different ISPs or internet service providers. We also have a web server that is hosting our website, as well as a DHCP server on the network that is assigning automatic IP addresses to client machines in the network. We also have two other switches, that is switch 1 and switch 2, connecting our two departments, engineering and sales department. So why redundancy? Redundancy is important in the sense that when there is a failure, a network failure or a device failure, then users should not realize that this has happened. So how do you achieve that? Is through implementing a redundant network. For a network to be considered reliable, it has to be scalable, fault tolerance, that means redundancy. The network also has to consider quality of service. So here, having these two routers in the same office and ensuring that they will be carrying traffic or serving as gateways for these clients, and when one router is down, the other router will assume responsibility of forwarding traffic. To further simplify this, I will make sure that this engineering and the sales department will be using one prefix, and we simulate selecting some few computers, giving them certain part of the prefix and the others on the other part, to ensure that we can do access restrictions based on their needs. This ensures security. So we go next is the IP address plan. The IP address plan is actually helpful in terms of documenting which devices are using which addresses. So here we have a simple plan. PC1 is assigned 192.168.10.1 network /24 with a gateway of 192.168.10.10. So you will see that our router R1 and R2 will be assigned physical addresses 192.168.10.253 and 192.168.10.254, but the client machines will be using a virtual router IP address to be acting as a gateway. This ensures that if any physical router is down, the other ones will assume the gateway role. So here we have the HSRP, which is a hot standby redundancy protocol that we are going to configure and enable this virtual router serving as a virtual gateway. So our web server is given that IP 196.24.0.2/30. So going forward, we will be setting up the IP address on the devices, that is the configurations, also enable routing configuration and test reachability. Then we move to the HSRP configurations, and we also enable our access restriction on the web services. We also do some port security to ensure that the ports on the switches is locked to certain devices and no other computers can use them for physical connection. So I'll be using the packet tracer as a simulation tool to do some of these configurations. To make sure that we keep this video as short as possible, I have applied some of the configuration, and I'm going to walk you through into the live device. So first of all, reviewing these configurations, you can see on the packet tracer we have switch 1 and switch 2 as it is being highlighted initially on our HLD or high level design. Switch 1 and switch 2, R1 and R2. So on switch 1, we will create a VLANs as virtual local area network and assign these two computers. And of course, it's going to be the same VLAN that we create in switch 2 and assign the other two computers, PC3 and PC4. So PC1 will be given the IP address 192.168.10.1 as you have already seen in our IP address plan. So switch 2 or PC2 also is given the static IP address 192.168.10.2, something mask of /24, and then the gateway of the virtual IP address which we are going to configure on these machines. So if we go to PC3 and PC4, we want them to be picking an automatic IP address. So they are picking IP address automatically from a DHCP server, and you can see that PC2 is being assigned 192.168.10.102. If you want also, you can verify that through the command line by issuing the command ipconfig, and you can see the IP address, the sender mask, and the default gateway. So this server here is acting as our DHCP server, and if you go to the IP configuration, it's also assigned a static IP, as it is a requirement for a DHCP server to obtain a static IP before you can set it up to assign automatic IP addresses to clients in your local network. It is also giving the gateway address of 10.10, which is going to serve as the virtual router. So, but still with the DHCP server, if we go to services, we could see that there are multiple servers that can run on this packet tracer server mode. So here we go to DHCP tab, and we give it a pool name, that's the IP address DHCP pool name, and we say that the default gateway for this pool is going to be the virtual router IP, and the pool range is going to start from 192.168.10, maybe we can say .10.100, and the sender mask is going to be 255.255.255.0. So we could save that, and here you can see that we can also restrict the number of addresses that we want to assign. So the next thing is we look at the switches. So for switch 1s, we have created a VLAN that is going to make sure that this PC will be communicating in the virtual local area network of VLAN. So by default, all ports of the switches are assigned to VLAN 1, and we say that for security reasons, you don't want to keep that configurations. So that's why we create another VLAN called VLAN 10, and we name it as sales, and we put this port FA0/1, which is connected to PC1, FA0/2 connected to PC2. So you could see there FA0/1 and FA0/2. On switch number 2, also we have created the same VLAN and assigned the ports FA0/3, which is PC3, PC4, FA0/4, and FA0/10 is the DHCP server. So the gigabit 0/1 and 0/2 are the links that are going to the other switches and the routers. So moving to the routers, we can look at the basic configuration, that is the IP address configuration. So if we display the interface configurations with the command show IP interface brief, you will see that the 0/0 is giving the IP address 208.60.10.2, and that is the G0/0 that is going to the ISP or going to the internet, and that is the IP address. G0/1 is giving the IP address 192.168.10.24, and that is the interface connecting to the LAN network. So this addressing was also shown here, as you can see in R1 G0/1, that was the IP, and the sender mask, the interface going to the ISP as well. So if you look at the configuration of the switches, the VLAN 10 was created with the command VLAN 10, and then it was given a name. VLAN 99 also was created, and it's for management purpose only. So by default, management VLAN is VLAN 1. This you also want to change for security reasons. So interface FA0/1 to 2, as I explained, also were being assigned to VLAN 10, and those commands will achieve it. So you put more access, we could access VLAN 10. So this additional configuration is for port security to ensure that the switches will be restricting access connections to only the computers that you want them to connect from there. So this security is important to make sure that not everybody can bring their machine and get connected to your network. So if you go to suite 2, also we do the same configuration there for port security and assign the interfaces to that VLAN. So on router 1, the IP address allocation is that command. You simply input that command IP address, put the IP address, and then send a mask. So that was also done for R2, basic IP address configurations on gigabit 0/1, that's the one connected to the LAN, and gigabit 0/0 connecting to the ISP with a different IP of 208.60.10.2, And now on the interface, the 0/2 on R2, that is the interface going to the server, web server. So if you move to the internet router, also basic IP address configuration has been done. You could see on the 0/0, okay, this IP address is assigned and the interface is enabled with the no shutdown command. So likewise, we created loopback address. This will simulate our DNS server. We are simulating Google DNS server here and give it a IP address of 8.8.8/32 with wildcard mask or with a Sunday mask of 4255. We create another loopback address also, and we give it an IP address 4.2.2 to simulate a public DNS server, as you could see it both in the packet tracer topology here. So again, on the configurations, the next thing we do is to enable routing. So routing normally is done to ensure that there is reachability. So here on our network, if you have multiple routers, they have what they call the local networks and the remote networks. So for R1, it has remote networks and also has local networks. So the local networks are networks that are directly connected to R1. So in this case, it's two. It's the one that is G0/0, which is 192.168.10/24, and the local network on G0/0, that's the one linked to the ISP 208.6010.0/30. But R1 needs to know about additional networks in this topology. So one of them is the Google DNS server, the public DNS server, the web server address, and even the one link between R2 and the internet router. So to ensure their reachability, we employ routing. Routing can be done in two forms, as the dynamic routing or static routing. So in this case, we are using an IGP OSPF, which is Open Source Spark Force, to ensure that routers can communicate and share routing information in this network. So the next configuration is HSIP configurations. So these are the commands in red. We first of all issue this command standby 1 IP address, and you put this IP address. So this command shows that this is the IP address of the virtual router, and that's what the client and the servers use as their gateway. And followed by another command, which is standby 1 priority 105. This shows that this router is going to be the master router or the active router. So the default priority is 100 or 100. The router with the highest priority in the HSRP group will assume the master role or the active role. And the third command there is standby 1 PM. So this means if you are the master router and unfortunately you have some fault issues and goes down, the next time you come back up on the network and somebody is running the active role, please preempt and assume the master role again. So on the other router, which is router 2, we issue only one command here, standby 1 IP, and then we'll put the virtual IP. So this sets this router with a default priority of 100, and which is lower than the 105 that was set on R1. So therefore, R2 will operate as a standby router, and R1 will be the master router. So we have configured routing, we have configured basic IP addressing, we've also configured routing, and all the PCs are also configured with their IP addresses. So let's test reachability. From PC1, I will go to the command prompt and try to reach the Google DNS server, which is sitting all the way on the internet cloud. So I will use the command ping 8.8.8 and should expect a reply, and there we go. So from the same PC, I should be able to ping the DNS server, the public DNS server 4.2.2.2.2. Okay, so let's see which path are we taking to reach these addresses, which is the Google DNS server. So I will use the command prompt traceroute 8.8.8.8, and here we can see we're going through the first hop of 192.168.10.2254. So even though that our default gateway is 192.168.10.10, which is the virtual IP address or the virtual gateway, we are going through the first hop as the physical IP address on R1, which is on G0/1. This is because this router is assuming the master role and is acting as the primary gateway. So if you say so standby, display that this router is running a standby mode and is on active mode. That means it's the router that is responsible for for the primary traffic. So you can see the priority is 105. So let's test that in the event that this router goes down R1, so R2 should assume the master role without PC1, even realizing that there is a network problem. So if I go back to PC1 and I do a continuous ping to the Google DNS server, and now I will attempt to create a network problem here by shutting down that interface which is connecting to the LAN network from R2, which is G0/1. That is interface G0/1. I just shut it down. So if I jump back to PC1, I should see some traffic interruption, and you can see that the request timeout means now the primary path that we were using to reach the Google DNS server, which was through this interface 192.168.10.254 in R1, is no more available. So the HSRP is now going to do the calculations and see the active router, the standby router, and that will assume the master role. So for traffic that was coming from PC1 to be diverted via the switch link all the way to R2 and Google DNS server. So the primary link was via R1 to this internet router and the Google DNS server, but now the second route will have to go via R2 and the internet router and reach the Google DNS server. So if I pull that back, you can see that the traffic is now back up. It drops some few packets, like request timer for some 4, 5, 6, 7, 8 packets, and now the master role has been assumed by this router, and you could see the traffic has been redirected. So it moves from standby to an active mode. So now if you issue this command, so standby, this router should now be assuming the master role of the HSRP. And you can see it's active. So if I stop this command and see which path are we taking to reach the Google DNS server, you could see that now we are going via 192.168.10.253 instead of before that we are going via 192.168.10.254, like here. Before it was via 254, but now it is via 253, which is the IP address on this gigabit 0/1 on R2. Okay, so let me bring that interface back up. So the next thing is we ensure that web access is restricted to PC1 and PC2 on the web server, and we deny all other people from accessing the web server. So to do that, we configure an access control list and R2 to ensure that PC1, which is 192.168.10.1, is allowed access, and PC2 192.168.10.2 is also allowed access to the web server for web services, and all other people's or all other users are denied access to the web server for web services, but other services to the web server like ICMP or management like Telnet SSH could be allowed. Okay, so let's go to the router R2 and we see the configurations. So in R2, I can say show access list, and now I've created an access list here, line number 10, that permits TCP from IP address 192.168.10.1, which is PC1 to the web server for web purpose, that's equal to port 80 or double. And line 20 also allows PC2, but line 30 is denying anybody else to this server for web services. Line 40 says, apart from web services, anybody is allowed any other service to the web server. So let's test that this is working from PC1. From PC1, we can test the web services. Let's run a web browser, and we say we want to access the web server HTTP /196 24.0.2. That's the IP address of the web server, as you can see it below down there. And let's try to connect. So we can see that it's saying open. So that means the connection was successful and we were able to access the web server. So let's go back and display our access list. We could see that the lines that permit PC1 to access the web server for web purposes has 6 hits. Okay, and it's captured there. So before, line 10 didn't have any hit. So let's try to also access web services from PC3. PC3 is not part of the range that is allowed to access the web server web services. As you can see, it's picking an IP address from the DHCP server with an address of 102. Okay, so if you launch the browser of PC3 and attempt to access the web server for web services, that traffic is expected to be dropped. Here we can see a request timeout. That means that this traffic was denied or rejected. And if we go to the router again and recall the access list, we should see there should be a hit in line 30 that is denying this PC from coming. So in line 30, you can see 29 hits occurred because this PC was trying to access the web server for web services, and that is not allowed. Okay, so now, but in the same PC, in PC3, I can access the web server for other services apart from web. Let's say like ICMP. I can ping the web service or the web server, that's 196.24.0.2. So this should be allowed, and you can see a reply there. So if I go back and recall the ACL again, I should see a hit that is on line 40 that permits any other traffic apart from web services. So you can see that access list will be processed based from the top line coming down. So you have to arrange this properly to ensure you achieve the appropriate filtering that you want to implement on your network. Okay, then the final thing is the restriction of users getting access to your LAN switches. Remember, these LAN switches are the first level of connection to your network, so you want to ensure that the physical devices connecting are the right one. To lock the connections of these devices, you can map the MAC addresses of devices to specific ports to ensure that only that MAC address or device could connect there. Any other computer or device that attempts to connect on that port, this switch can restrict the access or even deny you access. So the configurations we use to do that is applied on the switch. So if you go back to the switch configuration script, you could see that these 3 lines will do that for us. The first line says switch port security maximum is 2. So in this case, if you say maximum is 2, means you are allowing 2 people or 2 devices to get connected to the port. So most of the times you want to restrict it to 1, maybe maximum of 1. And to make sure it's that only device that can get connection to the device. Or you can even copy the MAC address and map it to that port. So here we are saying that we want the switch to learn the MAC address. I mean, the first device to learn the MAC address after the switch has restarted is going to pick the MAC address and stick it to the memory of that port. So that's why we said switch port security MAC address sticky. So if the right device was the first to get connected after the switch has restarted, switch is going to pick the MAC address of the device and mark it as one connection and will not allow any person else. For more security, you could physically copy the MAC address and map it to the port as well. So you can see this configuration in the switches. If you go to switch number 1, so here on facility 0/2, you can see that switch port security. This is command N port security, and we say MAC address is sticky, so it has learned the MAC address of PC2 and mapped it to that port. By default, the violation mode is shut down. So there are 3 different violation modes. Okay, so let me say if I go to the interface F0/2 and I said switch port security violations, you can use select 3. So that means shutdown means if anybody violates the MAC address rules, shut down that interface. So that means if the first device is connected, it should be remembered that and marked that as one device. The second device that wants to connect there, whether it's a hacker or it's an non-authorized user, the switch can shut down the interface, and you can only bring it up by the shutdown and no shutdown command. So if this violations mode is on restrict and protect, so this way the switch will not shut down the port but does not allow the next device or the non-authorized device to connect via the port. So for FA0/2, the violation is shut down. Let's try to attempt another computer connecting to the device, and we see how the switch is going to react. So I'm going to disconnect this cable. Let's say this one of these PC has shut down and leave the office. Another person will just come with his computer and try to have connection to that port FA0/2, and let's see how the switch is going to handle that. The switch now will attempt to make some traffic by picking an IP address, and you can see that the switch has shut down that port because you can see it now, it is red. So as soon as this PC connects to that port and attempts to send signal to the network, either by acquiring an IP address or trying to do any communications, the first communication message was sent to the switch, and the switch knows that this device is not the right device because the MAC address that was already there and this one is not the same, so it shut down this interface. So if I go to that interface, you will see that the interface is not up but it's not down. So interface FA0/2 is showing the interface is now on ERR disabled. So that means it is down. The interface is down and the line protocol is also down. So to fix these things, normally as a network administrator, you will be aware that somebody was trying to attempt connection to a network who is not an authorized user. So you will have to go back there and issue the command shut down and not shut down. So let's say this guy is gone because after trying physical access, he can't get connections. When this guy comes back and connect to the same port and found out that the port is down, you'll be contacted as a network administrator. You could log into the switch and bring the port back up for the right user. With the command interface FA0/2 shut down and no shut. So if you go back to the interface and display the interface status, now we can see the interface is back up and line protocol is also up. So basically, you can see that these simple configurations could help you get redundancy on a network. So this is what I have for you in this video. So thanks for watching, and if you enjoyed the video, please subscribe and I will see you in the next one.